Hey there, and welcome to my series about how to draw in perspective. Sorry that it took so long, a lot of things came in between. I have to go to the hospital, had to finish a drawing for a wedding present, had to take care of my friends, and so on and so on. And what took the most was I heavily underestimated how much research this series would take. And especially because there is a lot of misinformation out there actually about how to draw in perspective, and I want to talk about it a little bit before I start, but please don't click away because I think it's an important issue. Of course you can skip it, but it's up to you. Well, let me first explain. When you start drawing, like a very beginner, a kid or something, then what you normally do is you just get your paper and your tablet or canvas, whatever, and you just start drawing. And as time goes on and you get better, then you might want to get more advanced and start studying it. And when you study it, then you learn that you should not just do that. You should actually do some preparations, like get some references, prepare your colors to get a nice palette, prepare your tools for special techniques that you want to use. So you don't just start, but before that you do some work. And this work, these preparations actually help you a lot to draw much better. So it's very common for these more advanced artists that they just do this extra work, these extra preparations before they start drawing. Even though you might want to be lazy, but then you do more mistakes. So these preparations help you a lot. However, in terms of perspective, it's not that widely spread that you do it accurately. What you normally learn in books and websites and videos is you just set your vanishing point and all the lines go toward these points, and there you go, you draw in perspective. That's not how it is. These points have to be at a specific position and a specific distance and so on in order to be exact. But most artists just eyeball it, and you can make it look good. The difference between the professionals and the beginners is just experience. You know how to eyeball it. You know where approximately to set the lines so that it looks accurately. And beginners have a lot of troubles with that, and they have to do a lot of mistakes and try until they get to a level that is more or less okay. So enough of that. Let's finally start drawing. So, at first I have here my frame in which I will draw in, and this surface you draw on has to be within a certain circle that is called the cone of view. You can imagine like a cone coming from the eyes, and you can even test the angle of this cone. And you stretch out your arms and you also keep on moving the fingers so it's more easy for your eyes to see them. And you just keep on looking forward and you stretch out your arms more and more. And at the point where I don't see the movement of my fingers anymore, this is about the angle in which I can basically see. Now, this is very wide, of course, but what you're mostly focused on is what's right in front of us. Normal cameras, for example, also have a much smaller angle, of course. So you can kind of imagine again the cone coming from your eyes, and then you pick out the picture frame in which you're going to draw in. So this angle of this cone should be about like 60 degrees. So 30 degrees on each side from the middle. Why? Because of distortion. So to explain you that, I want to show you how the angle of rotation changes the size of things. So I have this cube here, and right from the front, when the rotation angle is 0 degrees, the length of this side, the size of this side here is 100%, right? And when we turn it to the other side, like 90 degrees, this length here goes to 0. And now, as we turn it around, the size changes. And how it changes has to do with the cosine function. You probably heard of it in school. Now the thing is about the cosine function, when we look here, is, well, we can see it starts at 1, like at 0 degrees we have 1, like 100%. And as we go to 90 degrees, it goes to 0. Now the thing is, for very low angles, the change of size is also very low. You can see we are still approximately at 0.9 or a little bit less. And as the angle increases, this change also increases. Like you can see the slope of this curve, which is at first very flat and it gets steeper and steeper. And the difference, for example, between 0 and 10 degrees is very little, but between 80 and 90 degrees it's very big, like more than 17%. So when we look at our cube again, if we turn it only a little bit, then the size of the front doesn't change that much. But when we start from 0, the change is very big. And so the reason why that matters is for very low angles, you can minimize the distortion. So I have here a straight line, and when you imagine the angle between the edges that come from the camera, at a great distance it is very low. And as I get closer, this angle expands. And now, as I get closer, also I will show you the distortion gets more significant. Because it's pretty much a straight line, but can you see that it's now curving? You can especially see it at the bottom of the camera. And the reason is the middle of this ruler is closer than the edges, and therefore you get this kind of distortion. The angle of this camera is not that wide, and therefore we don't have that much distortion, but there are wide angle lenses like fisheye lenses, or you can shoot a panorama photo and the distortion then gets very clear. And therefore, as long as we draw within the 60-degree cone of vision, we can approximate it with straight lines and say that's close enough. But as we draw further and further away from this cone, then this approximation of just straight lines would be very inaccurate, and therefore you get some very weird looking distortion. And for 1 point perspective, the center of this cone, circle here, would be also our vanishing point. And this line here is our horizon line, and I'm also going to explain you more about that. So I have here a 3-dimensional cube, and spoiler alert, there's also 2-point and 3-point perspective. I extended the edges of this cube here, and they always go to these vanishing points, and there are in total 3 of them. And on our horizon line we have these 2 vanishing points here, the left and the right one. And we get 1-point perspective if we first of all have no rotation at a vertical angle, and we also have no rotation in the horizontal angle, and therefore we have 0 degrees here for this vanishing point and 90 degrees for the other one. So this vanishing point here, the position of this vanishing point behind this cube would be like 0, and the position of this other one would go to infinity, and therefore we can approximate it with parallel lines. And the same goes for the third vanishing point. So you may already see it, 1 and 2-point perspective are just special cases of 3-point perspective when the vanishing points, 1 or 2 of these vanishing points, go toward infinity. So these lines we can approximate with parallel lines, and only these ones are going to this one vanishing point. So I can already spoil it for you, this horizon line here has something to do with the third vanishing point. And if this horizon line here goes up by tilting in a vertical angle, then this third vanishing point comes more and more into play. And I can also show you how this horizon line changes when we move our camera. So we have this cube here, and imagine at this point we have the camera, and this is the direction at which the camera looks. When we move our camera in a parallel way, that is just forward, backward, and on this plane here, then the horizon line will not change. And I can show you that. When we move our camera in exactly the way that I showed you, the horizon line does not change whatsoever. I can zoom out a little bit, but at some point the cube would disappear and the horizon line still stays at the same place. That is only if we have a plane that is infinitely wide. If we would go higher and higher in reality, the horizon that we see on our Earth would go down and down, because our Earth, of course, is not infinitely big. And also we have the curvature too and stuff like that. And so this horizon would go lower. But instead you can imagine a horizon line in front of your eyes, and as you move, this horizon line will not change whatsoever. The horizon line would only change if we change the vertical angle of our view. Here demonstrated to you, as I look left and right, it doesn't really change. but up and down, and you see how it moves. So we're not completely done. For example, we want to draw a square, a perfect square on our floor. So these lines go toward the vanishing point in the middle, and all the other lines are just parallel. Now, where do you put the last line? Is it about here? Or maybe about here? Which looks correct, which would be the perfect square. Now, with these tools that we have, we cannot tell. What we need are additional measure points or diagonal vanishing points. And these points are a specific distance from this cone of view. So what you need to do is you have these intersections with the cone of view and the horizon line. And then you draw 60 degrees. 1, 2, 3, 4, 5, 6. My tool goes always in 5 degrees angles. And right here the same. 1, 2, 3, 4, 5, 6. And it's about right. Now this point here is our station point, and we want to draw a 90-degree circle of view. We go from the middle again and then extend it until we touch this point here. There we go. And now these intersections are our measure points. Measure point 1 and measure point 2. And of course we have in the middle our vanishing point. Now there's a way to find the measure points with even less work, and this is by just calculating them. I made this link here where I already prepared everything, and all you need to do is to enter here, right here, the radius of the cone of vision, the circle that we drew before. So the distance between the middle point of this cone of view to the edge of it. In this case I drew the frame in which we are going to draw in a way that it is touching the circle on all 4 corners, and this is something that I highly recommend, because when you do that, the middle of this frame is always going to be the middle of the cone of view, and then all you need to do is to find the middle of this frame, which you can do by just connecting these diagonal lines, and then take this distance here from the middle to one of the corners. And of course your frame can have a completely different shape and still touch the circle at all 4 corners, or relative to the frame the horizon line is more up and down, or we set the frame at a completely different position. In this case you take the middle of the cone of view and just take the distance from this middle point to the corner that is the furthest away from it, and this will be the radius. So in this example here I have a distance of about 705 pixels. And so I just insert it right here, and it doesn't matter in which units it is. It can be centimeters, inches, pixels, it doesn't matter. And then we simply click on solve, and we scroll down, and D is the result. It is 1221 pixels. And when we measure it, we can see that this is about right. So what you can do, assuming you have a frame that is touching the cone of view at all 4 corners, is you just find the middle point of it by drawing the diagonals, and then the distance between the middle point and one of its corners will be the radius that you need. Then you will open the link, which of course I will provide to you down in the description, and then insert the value that you measured, get the distance from the middle point, which is also your vanishing point, to the measure point that you need, and both distances are the same. And there you go, you found all the points that you need without drawing any circles and angles or whatever. And so to go back again, and we want to draw a square, for example here with this 6-unit measurement, then all you need to do is you go to this corner and then you connect it with the opposite measure point. And then all you need to do is to draw the rest of the lines. Oops. And this intersection here gives you the exact position at where we need to draw it in order to get our perfect square. That's easy. And drawing the rest of the cube is very simple. We have here 6 units again. The same over here. The same over here. We have the lines going toward the vanishing point, and we draw those vertical lines and horizontal lines again. And there we go. And of course you can draw any kind of cuboid you want. For example, here at the front we have 2 units, and on the side I want to have 4 units, like right here. And going up I want to have like this here, about 6 units. And the front is very easy, I just connect it like this. And then we have these lines going toward the vanishing point. And now where to draw this line here. We want to project, as to say, we want to project this line here onto this line, and we can do it again by going from this corner and connecting it with the opposite measure point. And then we have at this point here exactly the position that we need. And there we go, we have this customized cuboid. Now we can scale these objects right at these spots, but let's say I want to draw this shape here exactly the same way, but more at the background or foreground. And how would this size change? And therefore you would need some sort of measurement scale, and this is what we have here, down here in magenta. So what you would do is you would have the corner where you start from, and then draw a line from the measure point through this corner until it touches this measurement scale. Now this is a little bit too far away, I would have to move all the way. So what you could do instead is you can move this scale, and so 4 units on this scale here would be about 1.8 units on this scale. And now when we connect this point here with one of the measurement points and cross the scale and then measure the other side of it, then we can get this translation of 2 units at this position here would be about, let's measure it, 3.6 or like 3.7. And now let's say I want to draw from this point here, alright? And then I take just the closest measurement point here and draw a line right through it until we cross the measurement scale. And as I said before, this length here is about 3.7 here, and we measure that to the right, so we draw also this side here on the right, and then simply connect it and draw the vertical line until it crosses this line that we drew before. And now we've projected this length here onto this position. We can measure again how long that is, about 2.5. So this length here is twice this one, and since we're on the left side in respect to the vanishing point, we have to start from here, and I want to have 5 units. 1, 2, 3, 4, 5. There we go. And this length here is 3 times this one here, so 7.5. 2, 4, 6, 7 and a half. Now we connect this corner here with the measurement point again, and then draw the line that goes toward the vanishing point until we touch the line that we drew before to the measurement point. And the rest is very simple. Just connect everything and we get the shape that we wanted. The exact same shape right here. So as you can see, it can get very confusing with the lines, so I recommend that you keep the colors maybe separated, or you draw with something that is easily erasable. What's also a good idea is to trace the lines that are actually visible and will be actually drawn in the end. Like you maybe draw them in a different color too, or just make them thicker. And when you do that, you can more easily tell them apart from the guidelines and all the other lines that you drew. Like this. Alright? So this is how you draw in one-point perspective. Be careful that the shapes that you draw are not too far away from the vanishing point, because as I mentioned before, you get distortion. Actually, this shape here is already distorted, because although the shape hasn't rotated on its own, since it moved parallel, it's still relative to us, relative to the camera, it has rotated. you can see this side, yeah? And therefore it is in a different angle than it would be right in front of you. So these lines here would actually go to a very distant vanishing point, and this way it would actually look more accurate. But it's close enough as long as we stay again within this cone of view. So for example, if we draw a shape all the way back here, the same shape over here, the same distance, and draw the lines towards the vanishing point and extend this one here, then you can see that this doesn't look right anymore. This angle is way too wide, so these are the limits. So as long as you stay within the 60-degree cone of view, then you're safe enough. So as a conclusion, one-point perspective can be used if the shapes that you look at are at the right angle from you, they are not rotated in any way, or like this, and the shapes have to have perpendicular angles, like this cube here, and it cannot be distorted in any way, but it has to be this kind of shape in order for the one-point perspective to work. So it could be useful for hallways or straight streets that go towards the horizon, something like that. So you see, doing these preparations is no big deal at all, especially with the calculator that I provided to you. Of course, you don't need to use this specific link, you can just use the formula that I also provided to you. It is in the calculator itself, and I will also provide a link to the research and practice sheet that I did for this one, and there all the calculations that I did are written on it. So next of all will be two-point perspective, and I promise to you this will also not be that difficult. Alright, it's Q&A time again, and the question that I got is, do you hear music when you draw or imagine the music or do it silently? Does the music have an influence at the time of start drawing? Yeah, sometimes I listen to music. Most of the time I just let some YouTube show running in the background or some TV show, or I draw together with friends and we talk at the same time, which I also like a lot. And yeah, sometimes it influences my works, it depends on. I did some drawings that were heavily inspired by music, but I don't do it that often. But of course it's a very nice idea to get additional ideas for what to draw. So the same question to you, do you listen to music while drawing, and does it inspire you in some way? So let me know down below in the comment section, where you can of course also ask me any sort of question that will maybe also appear in my Q&A section, or give me some constructive feedback or requests. And if you want to follow this series about perspective, then you may consider subscribing to this channel, maybe. And if you want to help me keeping the show on running, then you can check out my Patreon page. I want to keep on producing these videos that are free for all here on YouTube, and your support on Patreon would be very helpful for that. Alright then, have fun drawing!